Alright, in this screencast I'd like to concentrate on logarithms and the log function. So let's get that heading in here, the logarithmic function. In the last screencast we looked at the exponential function. And there it is there, and some aspects of that. We brought in this natural exponential value, this natural exponential function, and what this here e represents, and I asked you to recap some transformations and exercise 4f. So now the logarithmic function. Well, all right, let's get straight to it. I want to talk about what actually a logarithm is. So firstly, we shorten logarithm or logarithmic to log. So we're going to have a look at how to evaluate what this means here. Now that says evaluate the log of 8 to base 2. That's what this says here. The log of 8. The log of 8 to base 2. Okay, now what does that mean? Well, that means the solution to this, the value of this, is the power, the index or the exponent that you raise, or that you need to raise 2 to get 8. So what we need is, so that's the question we ask ourselves, what do we need to raise 2 to get 8? The answer there obviously is 3. So that is true because 2 cubed equals 8. So if you like, I've got my, this is called my base here. If I break this down, this is my base and this is my exponent. Now what we've got is our exponent is the subject of the logarithm, and the base here of the logarithm, or a logarithm has a base. So in this case it's 2, and the base here holds across there to 2. So it's this base to this exponent equals this number here. So if we have a look at another example, right, what is the value of log 9? Log 81 to base 9. So what do you raise 9 to? What exponent do you raise 9 to get yourself 81? Well, that's 2, isn't it? See if you can do the next one. What do you raise 4 to get 64? 4 cubed. Now what about log base 16? So log 4 base 16. So what do we raise 16 to get 4? Well, alright, so the answer here is, what do I need? What does 16 go to get us 4? Well, what's the relationship between 16 and 4? 4 is the square root of 16. So can we write, so I know that the square root of 16 is equal to 4. Well, 16 to the half is equal to 4. So my solution here is 1/2. So you can see what's going on with logarithms is that we need to know a little bit about exponents, about indices, don't we, in order to be able to solve these equations. Log of 8 to base 8. So let's have a look at some interesting properties here. So log 8 to base 8 is just 1, isn't it? Because 8 to the power of 1 is 8. What is log of 1? What's log 1 to base anything? So a to the what gives 1. Well, that's a to the 0 gives 1. Is it possible to evaluate log 0? Can I raise anything to the power of, can I raise 2, 3, 4, whatever, to the base of anything to get 0? Well, the answer there is no. So this has no value. There is no value to that. No value. No known value. Right. Okay. So let's have a look at the log function. If we start off with, let's go back to our exponential function, y equals a to the power of x. Now what I like to refer to this is I can write any exponential function as a logarithm, and I call it sort of logging in. So let's log in here, and the way to do that, I think, is to write your logarithm. Your base holds, and then it goes from there. A to the power of x, a to the power of x, so it's a to the power of x equals this value here. So this statement and this statement are exactly the same. This is logging in, and this is logging out. So that's how I'll sort of refer to this maneuver. So logging in is going that way, logging in is going that way, logging in, and this way here we call logging out, going from a getting rid of the log, putting the log in. Okay, so we started with y equals a to the power of x. Now we know, and this is exactly the same equation. Now we know y equals a to the power of x is graphs to something like that. Then if I now change let's interchange x and y here, then I get log x is equal to y. So what I've now got is I've started with y equals a to the power of x, I've written it as a log, I've interchanged x and y, I've got y as the subject. So therefore if we start with y equals a to the x, then the inverse function is log a to the x. So that's, if I say that this is my function of x, then my inverse function of x is log a to the x. So what that means is my exponential function here gets reflected in y equals x, and we get something like that. So this is my log function here. This is the graph of my log function. That's y equals log x. And we can have a look at different bases there. So there's my log curve. What else do I want you to know? I want you to know that there is such a thing as a natural logarithm. A natural logarithm, and it has a natural logarithm has base e. Okay, a natural logarithm has base e. It's written as log base e, x perhaps, or ln x, and that's how you'll see it on the calculator. Can you see down here, we've got there's our little blue writing on the second function of e to the power of x is just a little ln, that's log to base e. What you'll also see here, just to its right, is the log button, and that's log base 10, and that's called the common logarithm. So the common logarithm has base 10. Well, that didn't work. Has base 10, and we just write that as log x. So the default is, if you don't see anything here, is 10. It's the common logarithm, and ln, or log base e, is called the natural logarithm. So if we see evaluate log 100, then we assume a default value of 10 here with nothing written there. It's a bit like with a square root. If there's nothing there, we assume square root. Same sort of concept here. So log 100, so this is a 10, and we raise it to the power of 2 to get 100, so that would evaluate that common logarithm. Just have a look at a solve question. Let's have a look at solving an exponential equation, and logs can be terribly useful here. 10 to the power of x is equal to 0.2. Solve it. Now, up to this point, it's really been a matter of trial and error to get this value of x, but now we can use logarithms, because if we log in for this statement here, we can say, let's log in. This is what I refer to when I talk about logging in. Log in means write this as a log statement. So in goes log, my base is 10, so in goes 10 as my base. 10 to the power of, it's always 10 to the power of x, so this is the power of that. So my value of x is equal to log of 0.2. So we can go back in here, we can find this log button here, we can put in 0.2. So that is, if I just arrow across, I could put a 10 in there, or I could just arrow across to 0.2. It'll assume that I've wanted 10 there. You can see it's immediately reverted, and it's minus 0.699. So therefore, x is equal to minus 0.699 to 3 significant figures, and that's all good. Okay, let's go through now. We've exercise 4F was our exponents exercise, so now we can do G, H, I, J, K, L. G through to exercise 4L. That was an exercise 4G. That's a 4G through to exercise 4L. Okay, I'll see you soon.